And ladies and gentlemen, here we are back again with a little bit of geometry. Chapter 5, Section 6, Proving Triangle Congruence by Angle-Side Angle and Angle-Angle-Side. Alright, so if you have a couple of triangles like this, and they have two angles and an included side, there's only one way to put a triangle together if you have both these angles. Right? If this line keeps going this way and that line keeps going that way, they are going to cross right there at that point. So if you know these angles and one included side, then you can prove those two are congruent. Now it is important to note in this case, angle side angle, notice that's in the middle between those two, that's the included side of one triangle, is congruent to two angles and the included side of the second one. In the congruent statement, also notice that they have to be in order. A corresponds, this angle corresponds to D. Alright, the order matters how you write that, congruent parts. Okay, A is the corresponding vertex to D. A and D are in the first place. Okay, same thing with the other two, B and E, and C and F are in the same places. Alright, angle, angle, side, and you could guess this, that side is non-included. Angle, angle, side. So the non-included side, again, also with this situation, there's only one way to assemble that triangle. If you know this angle, and you know how long this side is. So if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included second side of a second triangle, then those two triangles are congruent. Alright, look at a couple examples here. See whether we can, by any of these theorems, prove these congruent with the information given. Alright, looking at A, we have this angle up here and this one. We know the side opposite it. What else can we deduce? We know this angle and this angle are congruent. Put a couple lines there. Those are congruent because vertical angles are congruent. And therefore we have two sides, two angles, and a non-included side. Therefore, two angles, angle, angle, side. Right here we know this angle is congruent to this one, vertical angles. We know these are congruent, but we have no sides. So since there are no sides, we have not enough information. Because you could create a similar triangle using those angles that's much larger and has the same angles. C, we know this angle is congruent to this one and this one's congruent to that one. So we have two angles and they share this side that's in between those angles. So we have two angles and one included side. Therefore, we can use angle, side, angle to prove that they are congruent. Alright, I know how much you love writing proofs, so we're going to do that right now. Make sure you put this down in your notes. Here we go. Statements and reasons. We are given that AD is parallel to EC. That's given. One. Alright. And then, based on this, we can say that this angle is congruent to that one. Okay, angle D, our second statement, is congruent to angle C because alternate interior to alternate interior. All right. Now we know this angle. We know a side and a side. What about this angle? Well, let's state the side because we just got an angle. We're going to state our side. We know that BD is congruent to BC. That is given. All right, we've got an angle, we've got a side. We needs an angle. All right, and angle B, angle 4, let's say ABD is congruent to angle CBE. Now in this case, it's not enough for me just to say angle B, because I don't know, do I mean this one over here, this one over here, on top or on bottom? Okay, so you have to be specific. Angle D, there's only one angle there. Okay, and 4, that is because of vertical angles. And therefore, we have another angle, so 5, they are congruent. Triangle ABD is congruent to triangle EBC because angle side angle. Boom. See? That's how easy a proof can be, just like that. All right, using angle side congruence theorem, write a proof. All right, we are given that HF is parallel to GK, and we know that F and K are right angles. We want to prove this. All right, so statements and reason. We know that HF is parallel to GK. That is given. And if this is parallel to this, then I can say that this angle right here is congruent to that one. So I can start making my case here. I've got an angle, got another angle, and then we're going to use this side right here. So 2, we know that angle FHG is congruent to angle KGH, and that is alternate interior angles. And then, thirdly, we know that F, and this is an angle. We know that angle F is congruent to angle K because all right angles are congruent to each other. Right angles theorem. That is another angle. And then we have a side right here that is non-included. And we know that HG is congruent to GH because 0.4 reflexive property. And that is a side, non-included. Therefore, we can say triangle HFG is congruent to triangle GKH because angle side. And that's how easy that is. All right, so here's a quick summary of the 5 different triangle congruence theorems. We have side angle side, side side side. In a right triangle, we have hypotenuse leg, angle side angle, and angle side. We looked at these 2 today. Now, in a right triangle, there's also hypotenuse angle. But technically, what that means is you know the hypotenuse, you know an angle, and another angle. So you know an angle side. So that one's angle side. All right? Or if you know an angle and a leg, an angle, the leg, and the 90 degrees, angle side angle. All right, there we go, angle side angle. And then leg, if you know both the legs, you know a side, the angle in between, and another side, side angle side. All right, So there's your summary of the triangle congruence theorems. That's all the fun we're going to have today. Check in again next time for another fun lesson.